So just to repeat our expectations for your practicals. So your TA and your CI will be looking at separate sets of things. So it's just recommended to have a wiki page for the CI and one wiki page for the TA. Your TA each week will need to see your task breakdown at the beginning of each milestone. You should be breaking up your tasks. Typically, it's in a table with one column of the person assigned to, one column of the completion date, and one column of the due date. So then after that, typically the TA will need to see a weekly update. So it's a summary of what you did the last week, because you'll be meeting with your TA weekly. And for the details, consult your TA. And for the tutorial, I will be covering how to start with coding for milestone 1. Here is at the top level how your milestone 1 looks like. We have the streets database library that is read-only. This is the library that allows you to access the data for your map. And this is read-only, so you cannot modify this. You have your main executable that's called whenever you start your program. You have your tester executable that's run by the auto tester. And both of these are already implemented. The only thing you need to implement is the street map library that serves as a wrapper to the actual streets database library for load, close queries, and etc. This is what you need to implement for milestone 1. To start with your milestone 1 coding, first thing, read your handout very carefully. There is no line in the handout that is not useful. And also your header files. You will need in your code at least one global variable to pass the performance tests. If you don't use global variables, then manage to pass the performance test using something else. We have not seen any approach that doesn't require one global variable, at least. Containers from the STL to store the global variables. You should be picking which container to store the global variables, depending on the usage. Your map is represented by intersections. Each intersection has an intersection ID that goes from 0 to number of intersections minus 1. The intersections are connected by street segments. Each street segment has a street segment ID that goes from 0 to number of street segment minus 1. Multiple street segments constitute a street, and each street has a street index that goes from 0 to number of streets minus 1. What you're given in the code, we include 2 header files that you need to read, both of them. There's the load map function that initially has to load from the street database API, and the close map that is called when the map is being closed. So you will need to load some map-related data structures in load map and clean them up in the close map. Without any modifications to the code, compile and run ECE297 exercise 1. This is after you're in it. You will see something like this. The build fails with errors saying undefined reference to functions. And this means that you have some functions defined but not implemented in m1.h. Open m1.h, and here are all of the functions that you need to implement. Usually, your task breakdown for milestone 1 is breaking down who will implement each function, which function, and group the related ones together. So you need to read through the requirements carefully in the beginning. In this tutorial, we will be showing this function. We'll be implementing this function with you. So to get around with the build errors, you'll need to create empty stub implementations of all functions in m1.h. If the function returns something empty. So if the function needs to return a vector, return an empty vector. Just so that you have placeholders for all of the functions that you need to implement in m1.h. And then run the ECE297 exercise again. Because we got around all of the build errors, you will get this test summary with all of them failing. Your goal for M1 is to implement all the functions so that you pass all of the functions here. So the tests are functionality tests for these 4, performance tests for the same tests, the tests for the runtimes, the load map test that just times your load map, Valgrind test that checks your memory leaks. The example function we're going to implement in this tutorial is find intersection street segments. The function requirement is in the comment in the header file m1.h. For this one, you need to return a vector of all the street segments connected to an intersection. So it returns a vector of street segment index. It takes in the intersection ID for the intersection you're looking at. Our only input is the intersection index number. So we need to use something that is outside the scope of the function to get the actual information you need. And that's Streets Database API.h. Let's read through the header file. For example, the street segment are stored in a street segment info struct. In this struct, it's defined by first OSM ID, way OSM ID. The OSM ID is a unique ID given to any of the elements in the OSM in the library that's unique universally. So there's nothing that can have the same OSM ID as this element that you're looking at. And this is different from the street segment ID. The street segment ID is going from 0 to number of street segment -1. So this could be overlapping. Intersection index, the from and the to intersection index. Each street segment connects 2 intersections, and these are the intersection index. One way signifies whether the street segment is one way. So it's either from to to, or from to to and to from for two-way. And we have the other things that are very useful for your drawings in milestone 2. Other functions that could be useful for this function that we're looking at, we have the get num intersection street segment that takes in an intersection ID. This gets the NSS, which is the number of street segments connected to the intersection from the name. We then, for each of the street segments connected, we access each of them using get intersection street segment with the intersection ID and the segment number that goes from 0 to number of segments minus 1. And this returns the street segment index of the street segment. We can then do anything else with the street segment info by getting the street segment info using the street segment index. Typically, the naming convention in street database API looks like this. A get that signifies a lookup of usually O1 complexity, number of street segments of the attribute, and the intersection is the entity that's usually given in the first argument. So it's the number of street segments for this intersection. Say we're looking at the intersection at St. George and Galbraith. It's connected to 3 street segments like this. First, we do the get non-intersection street segment 232. This returns 3 for 3 street segments. Then for each street segment, we do the get intersection street segment 232, 0, 1, 2. And this returns the respective street segment IDs. We can then do whatever we want with those street segment IDs by accessing the street segment info. We just need to be very careful that the type names, intersection index, street segment index are all type defs to int. So the compiler will treat them all as int. So if you accidentally put an intersection index into a street segment index, your compiler is not going to notice anything. So our recommendation is to use descriptive variable names. If you are defining a street segment index, say in the name that this is for street segment. Even if you just subscript underscore SS, that's enough. And in this case, you will be avoiding mixing of street segment index with intersection index and street index, for example. Now, implementing the actual function. Any ideas on how to implement this function? Yeah. Yeah, we get the number of street segments for this intersection. We loop through them. We get each street segment ID for this intersection, and we push back. Is this fine? So with this code, and we run the tester, ECE297 exercise 1, if we only want to run the tester with intersection in the name, we do -- run tester star intersection star. And this will only run the 2 tests with intersection in the name. And we'll find that the functionality test passed, but the performance test failed. And this is because the time complexity for this is still too big. In M1.h, we have the time speed requirement. And in the comment, it has the description. High speed requirement means this function must be very fast, and it's likely requires creation of data structures that allow you to rapidly return. Moderate, this function is speed tested, but you could use it in a more straightforward, brute force way, like just calling the streets database API functions. And if it's none, that means this function is not speed tested. For the function we're implementing, the speed requirement is high. So we have to create some global variable. What's the complexity of this function, assuming that all three of these functions are O1s? What's the complexity? O of n. We usually say O of k because it's not actually n. What is k in this case? K.
The number of the number of
It's usually the average number of street segments connected to the intersection.
yeah, that's what it
Connected to intersections. How can we speed up of a function? In load map, in your m1.cpp, it says load your map related data structures here. And that is loading up the global variables. What data structure can we use for that function specifically? So for this function, we're taking in as input intersection ID. This is an integer that's ranging from 0 to number of intersections minus 1. The output is a vector of int. Which data structure can have something stored like that? We have input, integer only, iterator, templated key, and output are all templated. So which of the data structures can be accessed with integer intersection ID? Vector and
and
everything else. Everything can be accessed with an integer. What can these data structures contain? Vectors and anything because they're templated. So if we want to access any elements in the data structure using an integer, here are the complexities. O1 and O1 for vector and unordered map. List is ON, map is O log n. And we want something less complex than ON. So we compare the two O1s. For the vector, we do a direct memory access, a load instruction that has the address and an offset. So a single load instruction. Unordered map first does a call to a hash function to get an index and then do a direct memory access. And the hash function takes time. So the unordered map, even though it is O1, it's still a bit slower than vectors. If we're doing something like accessing with an integer that's of a continuous range of 0 to some size minus 1. If we're doing that, can't beat a vector because it's just an array. In some other cases where the input is not an index, if we're not looking up with a number, we are looking up with a string, then we should be using a hash function on the map. If we're looking up with a very big number like the OSM IDs, the OSM IDs are enormous because it needs to be unique across all of the elements in all of the maps. So there's likely going to be many empty entries if you're using a vector. In that case, use hash. So let's create a global variable that's a vector of street segment ID. What this visually looks like, the street segment index is a type def to integer, so it's a vector of integer. The entire thing is then a vector of vectors of integer. And each vector of integer contains integers, arrays of integers that contains street segment IDs. And these indices are the intersection IDs. So if we want to access intersection 1 street segment IDs, we just need to do intersection street segments square bracket 1. And that's a vector. And to populate the intersection street segments, we first do a resize of the outer vector to be the number of intersections, because this number is fixed. And the resize operation creates empty vectors for all intersections. Then we go through all the intersections using a for loop. In the inner for loop, we get all of the street segments connected to the intersection. And we do the get intersection street segment intersection and I to get the street segment ID for each of the street segments connected to the intersection. And we do a direct pushback into the global variables indexed with the intersection. So intersection, street segments intersection is a vector. So we do a direct pushback of the segment ID. Is this good? Any questions with this page? And the line with the most confusion is the first line. Full load successful equal to load streets database Bing map name. What this line does is that it opens the load map for the streets database API. So it opens the map. Yeah. Yes. Yes. Yeah. You can just directly load whichever map you need. And then in the actual find function, it's reduced to just one line. Return intersection street segments, intersection ID. And this is O1. Single vector lookup to return the pre-calculated vector. And then in this case, the performance is brought down to O1, so we pass the test. And be careful, there is a performance test for load map too. So do not abuse it, but you still have several seconds to load everything. So this is plenty of time. Just make sure you're not abusing it by saving too much redundant and not necessary data into. And that's it. And I'll stay for a bit for any questions with milestone 1.